Good days to my fellow students. Welcome back to Mr. Lee physics class. So today we'll go through the geometry optics where the subtopic is refraction of curved surface. The aim of the study today is to study the refraction at curved surface. Lesson objective. In this lesson, students are able to state the phenomenon of reflection of light. Students also able to derive and use the formula of n1 over u plus n2 over v equal to n2 minus n1 over r. Assume prior knowledge. Students should already be familiar with Snell's law on reflection of light, reflective index, radius of curvature of a curved surface. Before we go through the reflection, let's revise some simple topics of the previous concept. So previous lesson, we learned about the curved mirror. So ladies and gentlemen, A, B, C, D, can you please tell me which two are convex and which two are concave? So I can set that this one, okay, is a concave mirror. Sorry. And the other one, okay, so A can be concave mirror, B can be convex mirror, and the C can be, for example, if I said that this one is concave mirror, okay, let's say, let me do something, concave mirror, okay. So this one, I can say that it's convex mirror. And C, it can be concave. C can be concave. And D can be convex. The important is if we said that if this one is concave mirror, means well, the object must at this side. This is the object. If this is the convex mirror, that means that this object will be at the right side. If this is a concave mirror, that means that object must be, okay, placed at this side. And convex, the object must be at the right side. So this is what is meant by the, okay, how we determine a concave and convex mirror. Because for this symbol, for example, this one, it can be concave, it can be convex. The important thing is where is the position of the object. So the position of the object is used to determine the type of the curved mirror. Okay, welcome back to our lesson for the reflection on the curved surface. So let's look at the fish inside the curved aquarium. So we notice that when the fish move nearer, the size of the fish become bigger. So why this illusion? Okay, why this phenomena happen? Because of the curved surface of the aquarium. Ladies and gentlemen, next we go to the next okay, we go to the next slide. We notice that, okay, the introduction, in this lesson, you will learn that the reflection of light, to derive and use the formula of n1 over u plus n2 over v equal to n2 minus n1 over r for the reflection at the spherical surface. You will learn the reflection of light by the spherical surface. Next. For the phenomena of the refraction, where reflection occurs at a plane surface. If there is a surface between air and water, that means that the optical density of water is higher than the air. Meanwhile, the angle of reflection in the water will be smaller than the angle of reflection or angle of incidence in air. The relationship between I and R as sin I over sin R is equal to constant, where it obeys the Snell's law. According to the Snell's law, sin 1 over sin I over R will be equal to the n, where n is a refractive index of a water, where the refractive is a constant. Next, if the ray passing through the first boundary in between air and medium 1 with the reflective index n1, and then it's continue reflected through another medium 2, okay, with the reflective index n2. Finally, back to the medium of A. So we notice that, okay, at the A medium 1, okay, A medium 1, the boundary, the reflective index n1 is equal to n1 is equal to sin I or sin I naught over I1. Sin I naught over I1. So we get that this will be the sin I naught, where n2 is equal to sin I naught over sin I2. So once we substitute in, we get that sin I naught equal to sin n2 sin I2. As a result, we can set that the reflective index between two medium will be equal to n1 sin I1 equal to n2 sin I2. That means that sin I naught, I can set that for these two medium, so this means n1 sin I1 equal to n2 sin I2. Okay. And next. If a light ray incident with an angle of 60 degrees, the reflected angle in glass or which is higher in reflective index, the angle will be smaller. If the light incident from the glass or with the medium with greater reflective index, so that means that when it's passing through, when it's reflect through the medium which is less optical density, that means that the angle of reflection will be greater in water. Ladies and gentlemen, as a conclusion, okay, as a summary, we can say that light is reflected when it's passed from one medium into another medium with different optically density, where according to the Snell's law, sin I over sin R is equal to constant, where the constant will be the reflective index. Ladies and gentlemen, let's look at the point object with the curved glass surface. When the light ray is incident to the curved surface, the light ray will be converged to a point, and all the light converge to a point where we can say that this will be the focus or the focal point. when there is a light ray passing through the principle of the optics, so we notice that it will be a straight line when it's passing through the medium with different optically density. If the light ray is towards other point on the curved surface, so the light will be reflected through a point. So the image will be formed. Let's say the image formed somewhere here. So that means that we have two medium N1 and N2. The distance of the object, distance of the image, radius of curvature or the radius of the curved surface. So we can notice that I1 is equal to A plus B. I1 is equal to A plus B. Okay, so and B is equal to I2 plus C. As a result, I2 equal to B minus C. Since the point A is close to P, the point A is close to P, so the angle I1 and I2 are considerably small. That means that sin I1 equal to I1 in the radians, and sin I2 equal to I2 in the unit of radians. The angles A, B, and C are small. For angle which is small, the angle in radians equal to its tangent. Ladies and gentlemen, by using the formula N1 sin I1 equal to N2 sin I2, where we get a N1 I1 equal to N2 I2 because sin I1 is very near to I1, sin I2 is very near to I2. By substitute I1 and I2 into the formula, we get that N1A plus N2C equal to N2 minus N1 times with B, where N1 H over U plus N2 H over V equal to N2 minus N1 H plus H over R. As a result, we get that N1 over U plus N2 over V equal to N2 minus N1 over R, where N1 is the reflective index of medium 1, N2 is the reflective index of medium 2, where U is the object distance, V will be the image distance, R is the radius of the curved surface. Now we look at the sign conversion for the for the V, U, V, and R. Object distance U is positive when it's real object. U is negative when it's virtual object. V is positive when it's a real image, and V is negative for virtual image. And the R, radius of curvature, is positive for the surface convex through the medium of lower refractive index. Meanwhile, the refractive surface will be the convex surface. So if the R will be negative for the surface concave to the medium of the lower reflective index. As a result, we notice that the equation N1 over U plus N2 over V equal to N2 minus N1 over R, where N2 minus N1 means, so this symbol means that it can be N2 minus N1 or N1 minus N2. Consider which one is greater. If N2 is greater than N1, then we use N2 minus N1. If the N1 is greater than N2, so we use N1 minus N2. Means what? That means that N1 over U plus N2 over V equal to N2 minus N1 over R, or it also can be N1 over U plus N2 over V equal to N1 minus N2 over R. Now we look at the three examples. For the curved surface, where this surface considered is a convex surface because object in front. Convex surface, that means R is positive. This is the concave surface, where the object is in front, concave surface, so R will be negative. This positive because R inside the curved surface, inside the reflective, inside the optical. This negative is because the R is outside the optical. And this one, object is here, image is here, so it's considered is positive or negative. So it will be positive. Okay. Why? Because we look at here, this consider is a convex surface. And don't forget, we notice that surface convex to the medium of lower reflective index. We'll look here, convex surface at lower reflective index. Convex surface at lower reflective index, so it's positive. If this one 1.5, this one 1, that means it will be negative. Understand? Okay, so from here we can conclude that n1 over u plus n2 over v equal to n2 minus n1 over r. This will be the equation for the reflection at a spherical surface. And the sign of the conversion, u positive, where is real object, u negative, where the object is virtual. V positive because real image, V negative is for virtual image. R positive for the convex surface, R negative for the concave surface. Next. Let's have some example. An object is placed in front of a convex mirror at a distance of 20 cm, where the reflective index of A is 1. Reflective index of glass is N2 is 1.5. What is the image distance? Where the radius, given that the radius of the curved surface, the radius of the curved surface is 10 cm. So by using the formula n1 over u plus n2 over v, where n2 is greater than 1, right? n2 minus 1 over r. We get that the v will be infinity, where the light ray will be in a straight line, in a parallel line to a infinity distance, to a very long distance. Example 2. If the object is placed in front of the convex surface, where reflection happen and form the image behind the object, or still in front of the convex surface, where u is equal to, let's say u is equal to 5 cm, the refractive index of A is 1, refractive index of glass is 1.5. What will be the image distance? Once we calculate, we get that the radius of the spherical surface is 10 cm here. So we get that the V is negative. V negative because it is reflection, FRAC. Object and the image at the same side will be virtual. So V is equal to negative 10. That means the negative sign shows that it's a virtual image, where the image is 10 cm from the convex surface. Let's go for another example of the concave surface. Let's say the object is placed 15 cm in front of the concave surface, where the N1 refractive index of A is 1, refractive index of glass is 1.5. We find the image where the R is equal to -5 because it's a concave surface. So we get that it will be -9. That means that it will be virtual image. That means 9 cm in front of the concave surface. That means 9 cm, the distance 9 cm. If, another example, if we place the object 2 cm in front of the concave surface, where 1 refractive index of A is 1, refractive index of glass is 1.5. We get that the image form will be -2.5, -2.5 in front of the concave surface. As a conclusion, we can say that for a spherical lens, the object, okay, so we look at another object, another example. What will happen if the image form outside the spherical surface? The image form. So that means that consider where the first object we place is at infinity. The radius of curvature is 2 cm. That means radius is 2 cm. Radius is 2 cm from the center. Okay, this one. Okay, so I use the straight line. Okay, from the center, this will be the R. R equal to 2 cm. When R equal to 2 cm, this means that diameter will be equal to 4 cm. Okay, so we calculate that, we get that the V, the image, the object is at infinity, the image will form at the 6 cm from the, 6 cm from the point we refer here. So from here, 6 cm, this means that the concave surface just with 4 cm only. This means that the image will another 2 cm outside the curved surface. 2 cm outside the curved surface at the other side. Okay, so let's see. Okay, once the light ray, the first light ray pass through the curved surface, the image will form 6 cm. The first image forms 6 cm because here will be the virtual image. So the image, okay, we go through the image will become, okay, will reflected again by this side of the curved surface. After that, it will form the final image here. So from here, reflective index N1 outside is equal to, N1 is 1.5, N2 is 1. So the yield is -2 because it is a virtual object. Virtual object because that is the first image formed by the left side of the curved surface. It will become the image formed by the left side of the curved surface become the object for the right side curved surface, so that the object is virtual because the object is not real. Not the real object here, just the image for the real object. Real object is at the infinity. Okay, so we calculate, we get that the V is equal to 1 cm. That means that this one is considered a convex surface now. So that means 1 cm is positive, that means 1 cm in front. Okay, so this means that the V is 1 cm. That means that from here to here, okay, it will be 1 cm. 1 cm. Okay, so that means that the final image is 1 cm from the other side of the the other side of curved surface. Okay. As a conclusion, we can say that in solving problems of reflection by a spherical surface, apply the formula n1 over u plus n2 over v equal to n2 minus n1 over r, where the n2 greater than n1. If n1 is greater than n2, this means you use n1 minus n2 over r and use the sign of conversion for u, v, and r. Draw a ray diagram to check your answer. The position of the image depends on the type of the reflecting surface and the position of the object. Ladies and gentlemen, as a summary for today's lesson, light is reflected when it's passed from one medium to another into another medium with different optically density due to the change of the speed. Snell's law, sin I over sin R is equal to constant. Where Snell's law said that sin I over sin R is a constant, it's equal to a reflective index of a medium. The equation for the reflection at the spherical surface is n1 over u plus n2 over v equal to n2 minus n1 over r, or n1 minus n2 over r. The sign of conversion of the object distance u positive where it's real object, negative for virtual object. Image distance v positive for real image, v negative for virtual image. R, radius of curvature, R positive when it's convex surface, R negative for concave surface. Again, in problem solving, we apply the formula n1 over u plus n2 over v equal to n2 minus n1 over r for the reflection by a spherical surface. And the position of the image depends on the type of reflecting surface and the position of the object. Okay. Sorry, just now forget to share the screen. So this is the question for today's lesson, question number 1. Question number 2. Question number 3. Question number 4. Question number 5. Question number 6. Question number 7. Question number 8. And this will be the answer for the question number 1. Question number 2. Question number 3. Answer for question number 4. Answer for question number 5. Answer for question number 6. Answer for question number 7. And also continue for the question number 7. answer for question number 8. Continue for the question number 8. That's all for today's lesson. Thank you and hope you enjoy my lesson.